Hello everyone. So in this video, we're going to discuss the concept of area between curves. Now previously, we have identified that the definite integral gives you the area under a curve. So paano naman if we want to find the area of a region formed when we consider multiple curves? So dito na papasok itong concept na to. We're going to be discussing two methods, yung using vertical strips and the other one is using horizontal strips. Okay, the area between curves using vertical strips. Suppose we have two continuous functions f and g on the closed interval from a to b where one function is always greater than or equal to the other. In this case, f of x is always greater than or equal to g of x for all x in that closed interval. So the area of the region formed by the two functions is given by this definite integral. Okay? So if we examine the given formula, ang nangyayari dito is, if we apply the properties of integral, so we have this, minus this. Okay? Now, refer to this illustration. Technically, the first one would give us this area. And the second one will give us this area. But we want the red shaded area. So that is how it works. Okay? And then, kaya vertical strips yan kasi we're using the fact that when we're getting the definite integral from a to b, we're actually dividing the interval into n rectangles, n vertical rectangles. Okay? So let's solve a couple of examples. I suppose we want to find the area of the region formed by y equals x squared minus x minus 6 and y equals negative 4. So consider the graph presented here. This one is y equals negative 4. It's the straight line or the horizontal line, and the parabola is y equals x squared minus x minus 6. Okay, we want to find the area of this region, the red shaded region. So we have to identify which function is f and which function is g. So, base sa graph, yung line natin ay always mas malaki or equal to the parabola. So, ibig sabihin, this is our f of x and this is our g of x. So, that would mean we want to set up muna natin. We want to get the integral of negative 4 minus x squared minus x minus 6 dx. Next, how do we get the bounds or how do we get a and b? We just have to identify the x values of the points of intersection of the two curves. Okay? So how do we do that? Well, if it's clear from the graph, pwede nang diretso dun. So from the graph, it's negative 1 and 2. But for instance, hindi ganyan kaganda yung x-coordinates or hindi integers yung x-coordinates ng points of intersection natin. We can solve it algebraically. We can treat the two equations as a system and solve for x. So we can use the substitution method to solve for x. So x squared minus x minus 2 equals 0. We have a quadratic polynomial which we can factor as x plus 1 times x minus 2 to get negative 1. Okay? So since we have the bounds and we have the setup, we can now proceed and solve this one. So simplify natin itong part na to. So we have negative x squared plus x plus 2 dx. Okay, solving this one will give us negative x cubed over 3 plus x squared over 2 plus 2x. We evaluate this from negative 1 to 2. So you have negative 8 thirds plus 4 over 2 plus 2 times 2 minus negative 1. Substitute natin. So 1/3 plus 1/2 minus 2. Last step is to solve and simplify. So yung first grouping natin, will give us, so this is 6 minus 8 thirds, that's 10 thirds. And then this part here will give us 5 over 6 minus 2. So negative 7 over 6. So magiging plus 7 over 6. Add 27 over 6, or that is 9 over 2. So the area of this region is 9/2, or 9/2 square units. Okay, so let's solve another. Okay, y equals square root of x, y equals x cubed. So from the graph, this is y equals square root of x, and this is y equals x cubed. Okay, so the setup of our definite integral would be the definite integral ng square root of x minus x cubed dx. Next, we have to find the bounds or the limits of integration. So from the graph, it would be from 0 to 1. But algebraically, we can solve it by considering this one and solving this equation. Okay? So I'll leave that to you as an exercise. Now, if we solve this definite integral, recall that the square root of x is x raised to 1/2. So we can have 2/3 x raised to 3/2 minus x to the 4th over 4 from 0 to 1. Okay, at x equals 0, mag-0 lang sila. So we just have to solve it at x equals 1. So that is 2/3 minus 1/4, or this will give us 8 over 12 minus 3 over 12, or 5 over 12 square units. Okay? And one more example. This time, let's consider 3 functions. So y equals x cubed, y equals negative x, y equals 1. Okay, in this case, we have three functions, no? We have this one, y equals 1. This one is y equals negative x. And this one is y equals x cubed. Okay, so we can divide this into two parts. Okay, let's consider this one. So this one is area 1. And then ito yung area 2. Okay, so the total area is given by area 1 plus area 2. Okay, in area 1, we can solve that by considering this definite integral. So the definite integral from negative 1 to 0 of 1 minus negative x dx. Okay? Kasi yung dalawang functions na kinonsider natin ay yung horizontal line y equals 1 saka itong line y equals negative x. Doon sa case na yon, lagi mas malaki yung y equals 1 compared sa y equals negative x. And the second area is given by the definite integral from 0 to 1 of 1 minus x cubed dx. So this part here is bounded by y equals 1 and y equals x cubed. Pero note na nilimit natin from 0 to 1 siya. Okay, so solving this one will give us 1 plus x, so that is x plus x squared over 2. We evaluate this from negative 1 to 0. Ito naman ay x minus x to the 4th over 4. Evaluate this from 0 to 1. This will give us, area 1 will give us, dito ko na lang lalagay, 0 yung una, tapos negative 1 plus 1 half. So that is negative 1 half, pero minus, so 1 half lang to. Then yung second one gives us 1 minus 1/4, or 3/4. So we have 1 half plus 3/4. So the total area is given by 5 over 4. Okay? Now, the second method, yung horizontal strips, would actually allow us to solve this easier. Kasi note na ang nangyari kasi kaya hindi natin makuha as a single integral is that dito sa part na to, yung two functions na ginamit ay magkaiba sa part na to. But what if ang i-consider natin instead of vertical rectangles ay horizontal rectangles? So kapag horizontal rectangles, more or less, laging ganyan yung itsura. Or, laging y equals x cubed, yung nandito sa part na to, at y equals negative x yung nandito sa part na to. Okay, so in some cases, it is easier to consider horizontal rectangles instead. So solve for to do that, we solve for x in terms of y. So again, dun sa ating illustration, we have this as y equals negative x. This is y equals 1 and y equals x cubed. So solve for x in terms of y. Itong part na to, madali lang, x equals negative y. Then itong part na to ay x equals cube root of y. Okay? Okay, so if we have two continuous functions, this time, ang variable of concern natin ay y, x equals f of y, and x equals g of y on the closed interval CD. So technically, parehas lang na yung f of y is always greater than or equal to the g of y. The area of the region formed by these two curves is given by this definite integral. So yung variable natin, instead of x, naging y. So, ang treatment natin sa function in this case would be horizontal ang orientation. Okay, so going back, we rewrite the given as x equals cube root of y and x equals negative y. Yung y equals 1, y equals 1 pa rin yan. Okay? So, let's just label this as x equals cube root of y, x equals negative y equals 1. Next, how do we identify C and D? So, technically, ang i-consider lang natin in this case ay yung y values na kasama dun sa region natin. Okay? Previously, dito tayo tumitingin sa x-axis. Ngayon, dito tayo titingin sa y-axis. So, ang kasama lang dun is from 0 to 1. So, yun na yung bounds ng ating definite integral. Next, ang i-consider naman natin ngayon is yung function na mas mataas yung x value niya. Okay? So, ibig sabihin, previously, ang tinitingnan natin ay kung alin yung mas mataas compared dun sa with respect to the x-axis. Ngayon naman, dati, with respect to the y-axis. Ngayon naman, with respect to the x-axis. Okay? So, in this case, yung x equals cube root of y, yung una nating function, at yung x equals negative y, yung pangalawa. So, cube root of y minus negative y dy. Okay, so having this, parehas pa rin naman na yung theorems natin sa pagkuha ng antiderivative still holds true. This is y raised to 1/3. So, 3/4 y raised to 4/3 plus y squared over 2 evaluated from 0 to 1. So, this gives us 3/4 plus 1/2, which is still 5 over 4. So, as you may have noticed, parehas lang yung sagot. Okay, one last example for this one. So, this one, using horizontal strips, is useful especially if you're considering curves which are not functional. Okay? Katulad nito. We have the parabola x equals negative y squared and the line x equals y minus 6. So, itong part na to, it's not a function because it fails the vertical line test. So, mas mahirap siyang gawin if we're going to use the vertical strips. Kapag horizontal, diretso na. Okay? So, in this case, x equals negative y squared is always greater than or equal to x equals y minus 6. Doon sa region natin. Oops, di ko pala na-highlight yung region. But it is this part. Okay? So, integral from negative y squared, integral of negative y squared minus y minus 6 dy, and get the bounds of integration. The bounds of integration in this case, same lang, we treat this as a system of two equations, two unknowns, and we solve for x in this case. So negative y squared should be y minus 6. Sorry, we solve for y in this case. So this gives us y squared plus y minus 6 equals 0. So y plus 3, y minus 2. So we have from negative 3 until 2. I solve this definite integral. This one is negative y squared minus y plus 6 dy, negative y cubed over 3 minus y squared over 2 plus 6y from negative 3 to 2. Apply FTC2 to get negative 8 thirds minus 2 plus 12 minus 9 minus 9 halves minus 18. Solve and simplify. So we have negative 10 here. 10 minus 8 thirds, so 22 over 3. Minus, we have negative 9 minus 9 halves. So minus 27 over 2. So this is 22 over 3 plus 27 over 2. Or 44 plus 81 over 6. We have 125 over 6 square units. And that is it for the area between curves. So to summarize, you have two methods. You can either use vertical strips or horizontal strips. Now, which method will be easier to use will actually depend on the graph of the curves.